Welcome, Michael Wickerson Studios. I'm going to put on 10 at a time of going back 4 years to my favorite scripts. If they're not mine, they'll be made public because they are public on GitHub, and I'll try and modify them and show some credit to who really motivated me. So there's some great groups, and I want to give them credit. And then the private repos every 10 as we step into it, those will be solely my creations from kind of scratch, obviously influenced by a few things. So I'm going to jump into here and do the top 10 in a nutshell, and they are totally available over here on Open Resource Source, Wickerson's favorites GH files public, and they come from the mesh edit tools, Lunchbox for the most part, Anemone, Octree, which is Parametric House, and Tree 8 manual, and a little bit of Buckman. And there are tens of thousands of scripts that I have to get through, it seems. So let's just get started. This one, the start, we'll jump into the first one, which is, if I opened it correctly, I think it's way down near the bottom. Tell you what, we'll go out of order, 10 all the way down to 1. So something that I really find helpful, and it's like Arturo Tedeschi's kind of guidebook. What I've done here is I'll put it on that I've gone into Buckman's books and translated out of that some GH Python scripts. And I think this is from chapter 2, and it was pretty simple. So to start, you're jumping in, you're getting an orientation, you're finding a circle, you're doing a polar array, and you're lofting it to build your torus. This tool for options is kind of nice, and the only thing I'm missing on here is, strangely enough, my bifocals tool, which is a plugin. I would recommend that's the one plugin you want to start with. The loft options is kind of just basically the simplest form of what you can do with the loft options. With or without that on here, you can probably go in and do a little bit of editing on the loft options just in this area as well. But nice little simple torus to start. And then there's lots going on. You get your 10 points. You can do a simple linear, but then things will add. I mean, you'll do another array, you can graph something, 10 points grafted, and this is going to play into the Occ8 tree, but this is good stuff to do. And then getting in the maths right off the bat, Daniel Kristev really influenced me. But you can see here, if I can just grab this correctly, I'll do a little zoom in here, and my file's a little big on, well, that's weird that it's shuffled over there, probably because there's too much on the file. So I'll just try and do a little rotation here and show you that you've actually used a little bit of math to pull off a 10-point grafted with equation x squared minus y squared, which is pretty nice to pull that out of a range and then put that into a point node system. Kind of nice to think about that as geometry. So continuing right along, and because I've taken this to display full inputs, we've done that again, and we've just lofted that area as well from the same range tools. There's a little bit tucked in here, 10 points grafted with the same equation, x squared minus y squared, and a surface from points node. I do like the mesh edit because I like mesh from points, and these files are up and ready for people to use. And these are open source, so just grab hold of them and do what you have with them. Flipping the matrix can be fun, so you can have a nice little sample here. Really nice introductory of these curves to these curves, and then that can be applied back onto that kind of torus idea of that ring, perpendicular frames, circles created. You've got your points between them and the lines running in this direction all the way around, but a flip matrix is going to put them in this direction. And of course I could close that if I wanted to, but I think I'll leave it open. That'll be fine. So just a nice little beginning of a torus. All right, so that's one script, and what I'm going to do is I'm going to jump in and grab another one here, probably Tree 8. Another great one coming out of manual. You got to go online. I don't think it's on Food for Rhino, but a really nice breakdown of people that understand working with trees with grasshopper can be key. So they set up a nice little box structure, put some geometries on it from a grid, and that's basically all they did to start. And with that, they take that right through the basic concepts of their custom nodes. And you have to go in and you have to grab these tree nodes and these list items, which are here. And this is a way to start understanding geometrically what's happening with your param viewer and what's going on. So this is a wonderful one that you can grab the first squares in that grid and the last squares in that grid, and then the remainders, everything in between that grid, which is actually over here. I think that's it. Let me see if the remainders is going to show everything But if I actually grabbed some data right here and took that, you'll see that I'm only grabbing those middle ones. So a nice use of that. Same thing, the first, the last, but going first end list versus the first end item, which is really nice. So you can grab this section, and then once again you can grab your data and you'd see that you have everything in between. And I just think these visuals are great to go through because it then gets more and more complicated. And you can take that, and I think they push it into a three-dimensional grid. So they take their grid, they bring it up, they put their boxes on, they have all their data, and then the same thing, grabbing the entire first section, the second section, and then the remainders in between. Over here, I think they've just put on the data they brought over and used the, if you don't know what's going on here, it's the wire display, and they put it on hidden, and then it's kind of telecommunicating over to where it is, and they've got their colors that I think if I went into shaded, you'd see, I think, yeah, the colors that are coming out. So that's a nice model to do that as well. Again, I just want to have this one off. And of course, if I take it off, I'm not getting that. But you've got your end items. You can grab this end and that end. So they're just pushing it into 3 dimensions. And they continue right along with the bottom and the top. And then they continue on with the end and the end, the diagonals, which is really nice. The smart end data list. So those are all really cool components. And then they're going to grab that flattened item again. They're going to flatten that item so it's all single information all the way down, boxes, 210 boxes. And then from that, they're going to show the data as that's driven from this node, which is data allocation B. And what do they do with that in here? I have to think about what they do. The data allocation numbers on the X grid, once again, from the flattened data, which came in. And I'm trying to think where they just allocate everything and show it again. And then they do have a little bifocals tool on here. They're bringing the data in. They're using tree statistics to show you everything that's happening here. And what's nice is this control of indices to play off the second and sixth indices. You can see you can grab here, and then you're allowed with the branches that you can grab specifically what you want to grab, which is these first two, the whole middle section, and then that last section up on top. So really nice data tree understanding for a simple cube, 3-dimensional cubes, and what's running. All right, so that's my second one that's like killer, and I think it's just awesome. Let me shut the Buckman down and not change it. Let me shut down the 8. Now, Voronoi 3D is a cute little small one from Parametric House, but I think it's worth playing with. They've got a nice little box that they bring in. They got points around that inform it with a radius on those circles. Those radii are a solid difference out of the box, and this is going a little more primary, populating that square, that entire area with points. And then from those points during a Voronoi 3D, from that geometry, using a box to kind of indicate that and the points for the Voronoi, and then a solid intersection between them all, so you're getting rid of the spheres, and then a nice solid union. Over here you can look at just the lines, which is a fantastic tool to take through and throw into subdivision tools, and you end up with this really nice subdivision, which wasn't around when actually I think Parametric House was making this script. So I'm just going to take that one off, and then using your breps, the surface, you can come in, find your centroids on each one, put your curves, another way to control those curves, and then throw a loft through those. And this becomes, I think I took this one off. No, it's very nice the way it's lofted these sections of these curves scaled and these curves scaled, and between them it makes these really nice windows, kind of prior to Weaverbird, but the thing I like are all these lovely geometries that are made from the negative in it. And then if you want to blast these out to the normals or from the center to the centroids of those objects, you can kind of move them away as if this is kind of explosive. So I've got a zoom window. So that's a nice little script, and it's a little more simpler. I think Parametric House does incredible scripts. You should follow through the tutorials. And I'm not trying to give away their scripts. It's like these are probably like you can find them. They're online. They're pretty cool. We'll get rid of 9 without changing it. We've done 8. Let's go down and see if we can see 7. This is another one from Parametric House, which I really like. I don't think I've edited too much of it. You're left with a point. You're left with other points. And this one's quite beautiful. So just closing a curve, and it's driven by those vertices. So those 4 vertices are forming that curve. You see that? That curve is then put through an evaluate curve at any point. So I can creep around that curve wherever I want. And then from that curve, I can show a vector in the direction. I'm going to use that just to visualize it, what I'm going to do, the tangents, and that's the point tangent So, and where that tangent is to that curve as it creeps around it. But then I take it through a rotate 3D, which is really nice, and it's what they do, and they kind of move this so you can open and close that entire kind of surface, which is really nice to get a hold of a script like this, play with the as much as you want to make it dense or hollow, and then they've got an incredible curve over here for remapping to the scale. So this remap scale is really nice for bending and warping and making these curves do beautiful things. And I think what they did was they put on a Bezier curve, if I think of the original, and they pulled it out, warped it in one direction to balloon it, and another direction. But it does make for some beautiful curves that you can quickly just throw into a loft and get a pretty basic shell shape that you can have control of. But then they go farther with these kind of points of stepping and repeating an item to jump through and pop these forms in and out, and you get this ripply little shell. And it really is a fantastic script that if you go back into it, I think sitting and doing the tutorial is nice, but if I open that up again and I actually manipulate, and I'm wondering why everything isn't jumping on. Oh, because I don't have all my viewing on. So if I jump in here, turn everything on, I can jump back into here, have these points, move them around, and they drive the form. Not only driving by that, but also that attractor point in the middle. This one can start to drive that form and work it. What a wonderful little script, and I think Parametric House kills it with projects like that. So that's one of my favorites. And I definitely think people should follow Parametric House and sign up for the classes and sign up for the courses. Octree is another one, very simple. Jumping in and grabbing a box, blasting it by points, and putting it through the Octree node. And I think Octree shows up in your meshes, and it comes in under triangulation. Maybe Octree, yeah, Octree comes in here if you get the mesh tools, or maybe it's always in there now. And then there's just a random reduce, so a very simple one of what they did, reducing those numbers. Not a hard script, but I think it's kind of exciting to get into the plugins and the simple tools and play off of it. And Parametric House does that really nice. I think I've got a little bit of population here that I can kind of play off of sides and have a lot of control. And they carry those through some really nice cluster nodes when you watch their site. So once again, Parametric House seems to be one worth doing. I'm going to close that. And we're going backwards, kind of counting down my top 10. Anonymy, 5 was Lunchbox. Absolutely my favorite. And I haven't done anything to custom this. I just want to show the power of it. These surfaces, which I used to build with Daniel Christev and mathematically, this is the one you want to get the downloaded proving ground ones, pull them in, they made in 2017, and start playing with them. So this one, if you think about it, is actually, if one item came in one sphere, this tool would actually predict with nonlinear regression that surface. And then it will guess where the next one is. I just think it's fantastic. What I've done is just taken with Mesh Edit, I've produced a mesh from it and a smooth surface from it. So that's the only thing I've kind of modified in this script. But otherwise, it's so well written. There's a whole bunch in the thing. If it had 2, 3, 4, you can see that you really have these objects kind of randomly jumping in and driving that surface. And then that surface can be controlled by I think these steps and patterns can kind of change it and simplify it. How many grid works do you want to do to have influence over that? And not only is this being produced because of what I've added in a sense of a mesh, which can be baked into an object, group it. You've got a wonderful mesh to pull out of here. Let's just lift that up out of the way. You've also got this, so if I turn off the mesh item, preview off, you'll see that I have an incredible surface from points, which comes which I just love, and I'm just going to group it, not that I have to. And then you get another one as a NURB surface off of that. So a model of prediction to spheres. What a way to populate a surface is actually to create the surface because of what was populated onto it. By far my favorite script. All right, and to follow up, probably a lot of Lunchbox now. Well, Anonymy's in here. I think it's fantastic. It's a sense of doing loops and packing between this tool and another one. And you'll see as I turn this on and start a count, it's going to predict from these points, 1 point starting to spiral out. One of my favorites, I think I made it from a tool off of Parametric House. It's hard to remember the spin force, but it'll reset itself as I set it to 2. It'll set itself setting to 4. It'll set itself setting to 10. It's kind of a growth algorithm that predicts itself, and then I haven't got it baking itself in, and I'm trying to use mesh spheres. but this loop of iteration is really fantastic. And if you don't want to slow it down with meshes, you can just do it with curves. And there's a little bit of, I think, flip matrix in there. Some simple spin forces, some working with fields, which should come out of, oh my goodness, where was all the field stuff? I think it came out of vectors. I think fields are in here. And they get jazzed up in Grasshopper 2.0, which we will get to. I'm going to try and simplify this and bring this out of 10 and put it back to like 2 items and just kind of watch it go. And if I want that script not to run, I'll just turn it back to 0 so it doesn't start. And then you've got all these other parameters that you can add to it. But Anonymy, one of my favorites. Hoop Snake is another one to play with if you really love it. So let's close the lunchbox. Let's close the Anonymy. Let's close the Octree. And we're just counting down. Lunchbox 3 is probably awesome. This is a predictive model for drawing a line. And I've done this with hops and done this through Visual Studio Code and done it with a hop server. But I really think Lunchbox came out and did this killer by just giving you data, training the data with that data, and then doing a predictive model of mediating in the middle. They've got a few color codes, very simple scripts, great to watch their hour tutorial. And I don't know, Lunchbox is like one of the best plugins that gets downloaded all the time. And I'm going to kill that one, the Anonymy. I'm going to kill, we'll go to Lunchbox, another one, another great pattern. I think all I did was throw some spheres on here just to make it colorful. But another predictive model of going through and using the Gaussian mixture of training the inputs, the random seeds. You're left with some points that are all pre-described. These points are actually, if I preview them, they're all already there. So they're all been inputted in these clusters. And then this group is wise enough in the data by the amount of components and sets you want to split up. So this is what's super awesome about this. Turn the preview off. We'll go over here. We'll click on those spheres. Actually, I think this one will give us our colors. And then if I wanted to put it into 6 groups, I could do that. I could do it in 7 groups, 8 groups, and the colors are going to be random. If I wanted 2 groups, it'd be 2 different colors split, and that's coming from using the data with this really nice create list node. And finding this out with the map to the parameter, what a great use of create set. I never would have figured that out on my own. And then the colors are basically all subdivided into the groups, and that's it. So really nice little node. Lunchbox, I can't boast enough about that. Lunchbox 3, what was the first one? Mesh Edit, which came out of just using Mesh Edit. Why did I choose it? Let's jump in here with the grid. There's our cube. We're going to put that onto a grid, and we probably could take this count up just a wee bit more, 2 by 2 or by 5, and this is going to slow it down by 3. We got all this information. We can build the cubes based on it. We can use the welding meshes, which is going to show you it went from 128 meshes, it minus 80 and went down to 48 meshes. So you're left with a really nice structure that can go to, and I like this little data of pushing through when you're ready for it. You push that data through and you make a delineate mesh from it. So Mesh Edit has all these awesome things you can use. There's your curves to the delineate mesh. And then you've got the 3D mesh cell that'll come out of it and produce this. A little bit of tree branch to pick in a section of it as you rotate through this list, and you can hand pick and train. The one thing in here that I love the most in this sample is to use the format node to say, okay, we're going to train this 0, 1, and we're going to input this data to whatever it is, 0 and 4, and that will drive which section of this path, 0, 4, which will run to the indices of what I'm selecting. So if I actually have that on, I think if I rotate through here, you'll start to see, oh, I bugged it out. You can see that I end up picking the other 4 patterns that go through, or 8. So I'm just going to slide that through 4 as that tree information. Those curves are selected, and those indices are what's influencing it. But as I roll through this now, and maybe I shouldn't get ahead of myself, maybe I should show the entire mesh of the 3D Voronoi. I should probably show, well, I showed the 3D Illinois. Now let's see the convex points. Let's show the convex hull, which can be used. But in the end, I really want to be able to pull out a couple items from these curves and slide through which one I want to grab. So there it is. Every little component can be grabbed as a kind of formatted tree information. So Mesh Edit comes up, and I think this comes out of that crazy listed Mesh Edit. I think if I go back and take a look at special folders, component folders, I think you'll see that that one's in here under this crazy name. There's tree 8. I thought it was a number. I maybe have it in another one. I don't see it listed here. Aviary. Mesh edit. I think that's it. Mesh edit there. You open it up and you can open this file. Mesh edit will show you that whole sample. A lot of people know about that when they pull it. Never really figured out plankton mesh, even though I kind of understand how they rotate clockwise and counterclockwise, but I'm not going to worry about them. So that's it. Those are my top 10 just to begin with, pulling from other people. What I am going to do is go into here, open, go into my C drive, jump, and this is for the people that are really interested in what I'm doing. I'm going to grab the documents and I'm going to slide through all of my GH files, and there are thousands of them. So I'm basically going through from the first days I was interested in late 2018, going through every one of these through Buckman, the ones that really motivated me. And after I get through Buckman, I'm going to do Weaverbird, I'll do Hoop Snake, and I'll do Flexhopper, which was absolutely incredible. And anytime these aren't my scripts, I'll put them on public sources because you can get these off of plugins and downloadable. But anytime there's something that I think I've created with catenary arcs, or if I've gone in here, you can see that this is going to be a master project of pulling 4 to 5 years of scripts together. And the ones that are my script, I'll make kind of private on GitHub through Patreon, and then the ones that are public, I'm just going to really have them pair. And if you compare it to like doing a math text book, every odd number of script will be, the assignments that we give, and then all the even number ones will be the ones that I was very playful in what I was doing. So I'm just going to grab everything here and show the complexity of that and what was driven by that. I always find this weird Rhino interface is a little hard to just select what you want to view in Rhino, because it just doesn't work if there's not real geometry baked in there. So that's it. Hopefully I can train as much people as I can, get them excited about Grasshopper, because some of my latest scripts are really about Grasshopper 2.0. So I want to sum up 4 years of study and then really roll with this. So that's it. We're going to stop streaming and we are going to stop recording.